This is lesson 13.1c. And after this lesson, you will do your learn and do's, and then you'll take the 13.1 snapshot. This lesson is the area of quadrilaterals continued. This time we're going to do a quadrilateral called a rhombus. Okay, so let's talk about what is a rhombus. A rhombus is a quadrilateral, which means it has 4 sides. And this quadrilateral has 4 congruent sides. Congruent means equal. In geometry, instead of saying equivalent, we say congruent, okay? So a rhombus is a quadrilateral that has 4 congruent sides. Well, squares have 4 congruent sides as well. The difference between a square and a rhombus is that the rhombus has opposite sides that are parallel. In a square, all of the sides, right? Like, so in a square, they have 90-degree corners, but in a rhombus, the corners are not 90 degrees. But everything else is a lot like a square, 4 equal sides, and opposite sides are parallel, but no 90-degree angles in the corners, okay? So it's kind of like a square, only like tilted, okay? So finding the area of a rhombus. Here we have, you'll notice that a rhombus has what's called 2 diagonals. A rhombus has 2 diagonals. Okay, so if we label the diagonals on this one, I'm going to just highlight this right here. Hopefully you can see that highlight. That is diagonal 1, let's call it D1. Okay. And then it has another diagonal right here, right? And we'll call that D2, okay? A rhombus has 2 diagonals, and those diagonals cut the rhombus into 4 triangles, okay? Those 4 triangles can be rearranged into make a rectangle, and from that rectangle, we get the formula for the area of a rhombus. So we're going to watch a video now that shows you how those triangles can move around, form a triangle, and then that's how you get the formula for the area of a rhombus. All right, here's the video. Our next shape, which is rhombus. Well, look, a rhombus is basically a parallelogram, right? The only special thing about a rhombus is all the sides are the same length. So this top and this bottom are parallel, and these 2 sides are parallel, just like a parallelogram, but it's a rhombus because all of the sides are the same length. Well, we could do the exact same thing. We could do base times height, right? We could. But what if we don't have that and we just have these here? These are called diagonals. A rhombus has 2 diagonals, right? Those are the 2 things that cut across from corner to corner. If you get those measurements and you don't have the base and the height, you can still find the area of the rhombus, and I'll show you why, okay? So I'm going to flip our rhombus down so that now we have a straight line across, and now we see those 4 triangles. This is D1, or this diagonal is D1 up and down, and this long one that goes across is D2. So we're going to make D2 yellow, and we're going to make D1 red so we can keep track of them, all right? And then what we're going to do is we're going to take these 2 triangles and we're going to move them. We can agree that this blue area is what we're trying to find. We're trying to find how much space do all these blue triangles take up, right? So we're going to move these 2, oh, there's D2 and D1. We're going to move these 2 triangles down, and then we're going to flip them over, and look what we just made. I know it's a little crooked because I couldn't make my shapes any shaper or straighter in the PowerPoint, but basically we make a rectangle, right? And we know how to find the area of a rectangle. The area of a rectangle is its base times its height. And we see what the base is. The base is D2. So we're going to find the area of a rhombus by taking the base, which is D2, and multiplying it times the height, which is half of D1. half of D1 went over here, and the other half of D1 went over here. So we're going to take the base, which is D2, and multiply it times half of D1, okay? All right, there you go. There is the formula for the area of a rhombus. D1 times D2 divided by 2, okay? So let's do that. Here we go. Here is the formula, area equals D1 times D2 divided by 2. We're going to do this one first. We'll do this one after, okay? Here's the first one. 2 diagonals, okay? We're going to take, it doesn't matter which one's D1 and which one's D2 because the properties say we can mix those up. So we're going to go 5 times 8 divided by 2. That's basically 40. 5 times 8 is 40 divided by 2, which is 20. So the area of this rhombus is 20 inches squared. Okay?
Okay, I'm going to stop the video there and we'll come back to the notes. And we are going to finish by writing down the formula. You can see that this says 1/2 D1 times D2. That is the same thing as area equals D1 times D2 divided by 2. Multiplying by 1/2 is the same as dividing by 2. Okay, it's the same thing. When you multiply something by 1/2, virtually you're doing the same thing as dividing by 2. Okay, so those two formulas are the same. D1 times D2 divided by 2 gives you the area of a rhombus. So now let's practice with this kite. Here you have a kite that has one diagonal of 24 and one diagonal of 15. So we're going to do area equals D1. And again, it doesn't matter which one you choose as D1 because the property of multiplication says you can change those around. You can multiply them in whatever order you want. And then D24 times the other D, which is 15, divided by 2. So if we do 24 times 15, you get 360. You divide 360 by 2, and you get 180. So the area of this rhombus is 180 inches squared. Area is a squared measurement, okay? So inches times inches is inches squared. All right, that is the area of a rhombus, and that's the end of 13.1.